Hey, this is Mr. Janes. In this video, we're going to be reviewing ratios and proportions and how they can be used in geometry. As you're watching this video, make sure you're taking notes, pausing to try practice problems, and rewinding when needed. To start, what is a ratio? Well, a ratio is a comparison between two values, A and B, where A and B stand for actual numbers, actual values. And the ratio of A to B can be written as a fraction, A over B, or like this, A with a colon, then B. So examples of ratios that you may have seen before are things like miles per hour. So you're going 60 miles in maybe 2 hours. That is a ratio. If you were buying something like wrapping paper and it cost you $10 per yard of wrapping paper, that's a ratio. And one that we all know is slope. Slope, or the ratio of the change in y to the change in x, that's a ratio too. All presented as a fraction, but it could easily be written as with a colon in the middle, like that. Okay. Generally, we will simplify our ratios. Just like we simplify our fractions in slope, we're going to simplify our ratios the same way. One place we often see ratios come up is when looking at televisions. Let's take a look at these problems down here. The screen on this TV is 32 inches wide and 24 inches tall. Let's mark that here. 32 inches wide and 24 inches tall. What is the ratio of the width to the height, also called the aspect ratio? So remember, the ratio of the width to the height can be expressed as a fraction, width being the numerator, 32 inches, the height being the second, the denominator, 24 inches. So this right here is our ratio, 32 inches to 24 inches. Now we can simplify that a little bit by dividing both the top, the numerator, and the bottom, the denominator, by 8, to leave us with 4/3. And 4/3 is actually what we call a standard aspect ratio. When you go and buy a TV, TVs usually come in two different varieties, a standard ratio, like this problem, or an HD ratio, which we'll do in a second. That impacts how the screen actually looks, whether it's more square, like this one, 4:3, or it's more rectangular. And so being able to do these ratios is important when you're looking at TVs. Pause here and try and find the aspect ratio for the HD television in the next problem. Please pause and try the next problem. The answers will be up on the screen in 3, 2, 1. So for this one, we've got a TV that's 64 inches wide and only 36 inches tall. And so we'll write the ratio of 64 to 36, also called the aspect ratio. And if we divide both the top, the numerator, and the denominator by 4, we'll end up with 16 over 9. And 16 over 9 is actually the HD aspect ratio. If you ever plan on buying a big TV or maybe creating a home theater system with a projector, then you'll actually have to think about these aspect ratios of 4:3 and 16:9. Right, what we have right here is a guide from Best Buy that actually tells you which different TVs to buy depending on what you're looking for. Right? If you're looking for more of a older TV, you're going to be playing older movies, then 4/3 is what you want to go with. Right? On the other hand, if HGTV programming is what you'll watch most of the time, you're going to go with a 16:9 projector. Now remember, 4/3 is just a ratio, a comparison between two numbers. So any TV that simplifies or falls into this ratio has this 4/3 or standard aspect ratio. For example, another kind of TV that would have this aspect ratio might be one that's 4 inches wide by 3 inches tall, or something that could be 8 inches wide by 6 inches tall, or even 12 inches wide by 9 inches tall. They all have this 4/3 aspect ratio. Now if we wanted to simplify a ratio like what we see here with A, we run into a little bit of an issue. The top units are in centimeters and the bottom units in the denominator are in meters. So what we're going to need to do is convert these units to either both centimeters or both meters before we simplify our ratio. It'll be easiest if we convert meters to centimeters because I know that there are 100 centimeters in 1 meter. So what I can do is rewrite the top, the numerator, 12 centimeters, and the bottom will be 4 times 100 centimeters. All I'm doing is replacing meters with 100 centimeters. The bottom, 4 times 100, becomes 400, and now we have ratio of 12 centimeters to 400 centimeters. We can simplify this ratio to 3 over 100. Again, because we can divide both the numerator and the denominator of 12 over 400 by 4 to get 3 over 100. Pause the video here and try and simplify the ratio in B. Remember, there are 12 inches in 1 foot. Pause the video now. The answers will come up in 3, 2, 1. So here we are. The important things to remember are that I converted from feet to inches, and to do that I replaced the feet with 12 inches right here. So 6 times 12 is 72 over 18. I divided both the numerator and the denominator by, 9 to get 8 over 2. But in fact, I can simplify that one step further because both the numerator and denominator can still be divided by 2 evenly for a final ratio of 4 over 1. So far, we talked about ratios where you're comparing one number to another. But what's a proportion? A proportion is a statement that two ratios are equal. So for example, they can be written like this. One ratio, A over B, is equal to another ratio, C over D. Or they could be written using the colons. A colon B is equal to C colon D. For example, a proportion could be that 1/2 is equal to 2/4. That's a proportion right there. If you have more than two ratios, we call it an extended proportion. For example, 1/2 is equal to 6 over 12 is equal to 50 over 100. We could even add a couple other ones. We could say that's equal to maybe 30 over 60 or 5 over 10. Again, this is when we have more than just two ratios. That is an extended proportion. On the back of the notes, we're going to start solving proportions in just a minute. But first we need to talk about how we can solve proportions, because something like this, A over B equals C over D, is not something we've normally seen when we're solving equations. Usually it's just one expression without any fractions equals another expression without any fractions. So how do we deal with these fractions? Well, let's think. Let's try and get this B out of the denominator. How can we do that? Well, let's think about inverse operations. This is A divided by B. What's the inverse of dividing by B? It's multiplying by B. So if we multiply both sides of this equation by B, we're left with B over B on the left-hand side, and B over B is 1. Those cancel each other out. Similarly, we need to get D out of this denominator. So multiply both sides by D. What that does is on this side we've got D in the numerator and D in the denominator. D over D is 1. They cancel each other out. And we're left with D times A equals C times B. Let's write that over here. D times A equals C times B. Now you may have seen this in the past and called it cross-multiplying, right? When you have two fractions like this, you can just multiply A times D and C times B, just like we've done over here, and then solve that equation to get your answer. And that works, although I don't really like to use the term cross-multiplying, because sometimes we'll be adding fractions or multiplying fractions or subtracting or dividing fractions, and in those cases you can't just cross-multiply like you can when two fractions or two ratios are equal. So you can think of this as cross-multiplying, but I prefer to think of it this way as inverse operations, right? I need to move the D out of there, so I multiply this side by D. I need to get the B out of this denominator, so I'll multiply this side by B. And so let's actually try and apply this to some problems. At this point, if you feel comfortable solving proportions, or if you've seen these kinds of problems before, go ahead and pause the video now and try and solve the next 4 for the missing variables. Otherwise, we'll go ahead and do them. So let's take a look at the first one. This is a pretty straightforward proportion. X over 5 equals 12 over 7. The first thing to do is get this out of fraction form. To do that, we start by multiplying both sides by 5. Again, because that will cause these to cancel out. And also multiplying both sides by 7. Again, because that will cause these two to cancel out. And so you'll see pretty quickly that this is going to be 7x equals 12 times 5, which is 60. The only last thing to do here is divide both sides by 7 to get that x by itself. Remember, we've got 7 times x, so we divide by 7 as an inverse operation. And x equals 60 divided by 7. We could leave that as a fraction or as a decimal. Put that in your calculator, and you should get about 8.57 if we round to 2 decimal places. This next one's a little more challenging, but still not too bad. We're going to go ahead and multiply 4 over here and 8 on this side. And we end up with 4 times y plus 3 equals 8 times y. Now, one common mistake people make is they rewrite this as 4y plus 3. But that is incorrect. When we multiply 4 times the side, we have to distribute it into both the 4 and the 3. So this becomes 4y plus 12, 4 times 3, equals 8y. We finish by subtracting 4y from both sides. We have 12 equals 4y, and dividing both sides by 4 to get the y by itself, and we end up with 3 equals y for the second problem. Our third problem is again a little more challenging, but still not too bad. If we multiply both sides by 32, and also by x, we get 32 times 2, which is 64, equals x times x, which is x squared. How can we solve this? Well, we've seen this before with Pythagorean theorem. The inverse of squaring is a square root, so we take a square root of both sides. The square root of 64 is 8, and so 8 equals x. If you're unsure that this works, you can simply plug 8 back into the original equation. 2 over 8 is equal to 8 over 32. This makes sense because if you simplify the fraction 8 over 32, you'll end up with 1/4, and if you simplify the fraction 2 over 8, you'll also end up with 1/4, which means that these two ratios are equal, and we solved the proportion. The fourth problem here is an example of an extended proportion. That means that we've got more than one ratio that's equal to each other. Remember, all three of these ratios equal each other, so what we can just do is only take a look at two of them at once and solve for the variable. So look at the first two ratios as a single proportion. So we can write down that we've got 1 times 3x is 3x equals 2 times x plus 1, and so that'll be 3x equals 2x plus 2. If we distribute that 2 in there, we can subtract 2x from both sides, and we're left with x equals 2. And then we can go ahead and even fill that in back up here. That'll be 2 plus 1, which is 3, and 3 times 2, which is 6. So this fraction is 3 over 6, which makes sense because that is equal to 1/2. Next, to solve for y, we'll pick this ratio and either of these other ones, right? For simplicity, I'll use this first ratio and this last one since they only involve the variable y. So take a look. 1 times 3y plus 5 will be y plus 5, and 2 times y will be 2y, and there is my equation. I can subtract the variable y from both sides, and 5 equals y, and so y is 5. If we wanted to plug this back in to make sure it worked, this would be 5 on top, and 5 plus 5, which is 10. 5 over 10, that's the same as the 3 over 6 we had before, or 1/2. So I found that x is 2 and y is 5. That ends the first video on ratios and proportions. In the next video, we'll spend a few minutes talking about how we can apply ratios and proportions to real-life situations.